All right. Last Friday, you took a little Google quiz of 10 of my very favorite problems plus one um, that is almost in my top 10, but still a problem I like a lot. Um, I didn't grade them because Google graded them. I guess I did look at your names, and I'm happy to tell you that all 24 people that took this quiz got their name right. So congratulations. Um, these are the numbers that came out of the quiz. Boy, I mean that would be kind of scary, right? 12 out of 23 is barely over 50%. However, remember there's a 3-point bonus, so it was really about 12 out of um, 20, which would be 60%. Actually, 12.25 would be 61%, which is still not very good, is it? So why would that be the case? Well, we'll figure out why that average is probably lower than it needs to be. Um, there were four primary problems, well, plus the bonus, but four primary problems that they would consider frequently missed. And you can see that very few people got these five questions right. Um, these these two right here you're gonna see those are my fault. This one and this one, my bad. However, only six people got number one right, and only three people got number five right, and those weren't really my fault. We're gonna have to look at those and see what happened on those problems. So let's get going. Um, Problem number one was our first problem that had a little bit of a low score on it. Anytime you see these multiple select problems, I think they're always going to be more challenging. I know that it's kind of annoying the way the layout was on the quiz because you had, these huge boxes for the things, and that probably makes it a little harder to keep track of. But I can't type this stuff into Google. I have to take little pictures of these uh, of these statements because of the notation, the symbols, and then import it into Google one at a time as pictures. So it's really annoying to make these these quizzes. Um, and so sorry about the formatting. Um, I think the main reason that so many people missed this one, when I glanced at it, was because of this one right here. So let's go through and take a look. Is TW a radius? Well, according to the definition of a radius, there's actually two of them, right? Because it could be the length of the radius, but it could also be the radius itself, the segment with one endpoint at the center of the circle and the other point on the circle, right? So what I see here is a segment with a point on the circle and a point on the circle. So yes, absolutely, I think that one should be checked. Um, Option two, segment ZY is a secant, right? ZY. So is this a secant? Well, no. A secant is a line that intersects a circle. A line, and this is not a line. I mean, this very clearly is a segment notation. There's no arrows on that. ZY is not a secant because a secant is a line. Now, we will learn about something called a secant segment down the road, but it's a very specific definition, and it's not that. In fact, we already have a definition for what we see right here, ZY. It is called a chord. A chord is a segment who has endpoints on the circle. And that's exactly what this is. So a secant will always contain a chord because it'll pass through the circle. So if this is the secant line, right, it will contain the chord. But a lot of you guys, I think, missed that problem because you weren't thinking, you weren't paying attention to detail. Let's just put it that way. You've got to not just glance at your definitions. You really have to study them and understand that a secant and a tangent are lines, whereas radii and chords are segments. Okay. Speaking of chords, Option 3, XY. XY. Well, it goes through the center of the circle, so that actually makes it a diameter. But a diameter is a special type of chord. A diameter is the longest chord in a circle. So I would actually definitely say that one was true. And the measure of angle WTY. So WTY is this angle. Has the same measure as arc YW. First of all, notice that that arc is a minor arc, so it only has 2 points. And second of all, notice that it is the arc that this angle intersects. And we talked about how there's a one-to-one relationship between this measurement and this measurement. The central angles will always intersect the arc. So yes, that is going to be true, no doubt about it. What about the last one? YW is a major arc. Well, we only used 2 letters, so no, it's not. It's not a major arc, it's a minor arc. If I threw an extra letter in, like a Z or an X, and went around the other way, then it would have been a major arc. But major arcs and semicircles are named with 3 points. Minor arcs only with 2 points. Here's that relationship about the measurement of a central angle is exactly the same as the arc that it intersects. And this is not a theorem or anything, it's just a key concept, but it is in the book. And then here's the definition of a major arc: greater than 180, less than 360, which YW was not. So we break this one down and we see that everybody that took this got option 1 correct. So that's great. That's part of the problem right there. And almost everybody got option 4 correct. That was the measurement of the central angle in the arc. So that was also really good. Now, 2/3 of you guys got option 3 correct. Actually, that's pretty close to 3/4. The problem was almost as many people picked option 2. And you missed the problem because you got to get them all right to get the problem correct. So please make sure you know that secants and tangents are lines. This one was definitely a state of emergency, but only, I think, because of that one technicality. And hopefully this will now convince you of that fact. So number 2 was not a real big issue. You guys did pretty well on this one. I'll show you just how well in a second. It asked which of the following was a central angle. So a central angle has to have its vertex at the center. There's a very direct relationship between the word and what it is. And so really just glance at the vertices. This has vertex Y, so that's not correct. This is actually something you will learn about on Wednesday this week. So I guess that would be tomorrow. That's called an inscribed angle, and we'll talk about those tomorrow. TWV is an angle made by the tangent and the radius. So we know it's 90 degrees by theorem 10.1, but it's definitely not a central angle because the vertex, right? The vertex is not at the center of the circle. Let's see here, XTY, XTW, yeah, that one, even though I didn't trace it very well, has a vertex at the center. That one looks like the one that we're after right there. That one, I believe, is your right answer. And I think that the option 4, TWX, isn't even an angle because it's made up of a line segment and an arc, so that's not even an angle. And then angle T doesn't exist, even though point T is the center of the circle. There's multiple angles at that vertex, so you cannot name an angle with only one letter if it has multiple angles coming out of that vertex. And so, although T is the right point for the vertex, it's not a known angle there. And a central angle has its vertex at the center of a circle. The only one that did so was option option 3. And you guys knew that because only one person got it wrong. So well done on that one. You did a good job. No false. You did an awesome job. Problem number 3. TW is a segment. You can see that I spelled it out here because otherwise I couldn't put the notation in. And line WV is a line, and they would best be described as what? Well, it looks like WV is a tangent line, and TW is a radius, and I believe it's theorem 10.1 that tells us that in a plane, a line is tangent to a circle if and only if it is perpendicular to the radius drawn to the point of tangency, basically is what it says. And so perpendicular is the magic word on that one. All right, we'll go with that option. And how did you guys do on this one? Oh, pretty well. Every single person that took this got that one right. So bravo. Such a good job. I cry at your amazingness. You made Brock cry. That's awesome. Number 4. Given the figure below, we want to find the measure of angle ASK. Once again, I spelled it out because I couldn't put the notation in. So angle ASK. Make sure you know which angle is correct. Okay? I think some people sometimes don't read those carefully. Well, here's what we know. We know from theorem 10.2 that tangent segments from a point outside a circle that are drawn to the same circle are congruent. And so this segment right here is congruent to that segment, which makes this an isosceles triangle, which means that these two base angles have to be congruent. So if I know that this angle right here is 50 degrees, all I really should need to do is subtract 50 from 180 degrees in the triangle and then divide by 2. 130 divided by 2, what is that, 65 degrees? Now notice I said do not include units or degrees in your answer. That's really something you have to pay attention to because I have to input the answers to these. There's no degree sign, so I couldn't have you include that. And so there's a lot of, people might put 65D, 65DEG. They may put a space between them or not. They may spell out degrees. And there's no way for me to put every possible option. So when I give you specific instructions about how far to round off or not to include units or how to spell your units or write your units, you really, really have to pay attention because Google doesn't know anything other than what I tell it. And so you really got to do that because you may get a right answer and get the problem wrong if you don't follow directions. So in the future, please consider that. You guys did well on this one. You can see that there were a couple people that threw some different answers in there. And now that you see how it's done, maybe go back and examine that. But that's not as good as the first couple, but it was pretty solid. So nice work. Maybe not awesome work, but still nice work. So good. Number 5 was the problem that you guys I think struggled on a little bit. Let me go back and look at see, it was what I thought it was. It was an oopser. Okay, so why was it an oopser? Well, let's figure this one out. When it gives you information, you really should draw it out as much as you can. So give yourself a little circle, and the center of the circle was O. Not that is a big deal, but what is a big deal is that there's 4 points on the circle, right? A and B and C and D. And furthermore, this is really important right here, BD is a diameter. So let's connect B and D through the center of the circle. Okay. Now, the only other thing it tells us is that A and C are on opposite semicircles. Okay, so if A is over here C is over here. You can't have them both on the same, okay? And then we just have to go through and figure out what we know, okay? Is AC a semicircle? Well, first of all, that's impossible because semicircles um, are not named with 2 letters. They're named with 3 letters. And second of all, we don't know exactly where A and C are. I mean, A and C could be, they could be the endpoints of a semicircle. They could. But it's very unlikely given that there's infinitely many places for them to be located. They could be as close as right here where they don't make a semicircle, or you could actually, go around the long way and say it's a major arc. Either way, it's not going to be true. Um, what else? Arc B, C, D. So because B and D are the endpoints of this arc, and B and D are the endpoints of the diameter, there's no way that that cannot be a semicircle. That has to be true. That absolutely um, has to be a true statement. Okay, so we'll mark that one. Give it a little, X. Um, oh wait, I'm sorry. It didn't say semicircle. It said major arc. Okay, I'm taking away my X. It's not a major arc, it's a semicircle. Um, so I think we know why it's not a major arc. It's a semicircle. Arc CD. Arc CD has to be a minor arc because C is, um, within the semicircle, one of the semicircles being D form, and so it can't be a semicircle, and it's only 2 letters. And so that means we're doing the short route from C to D, no points in between. So that one um, does have to be true. What about DBA? DBA. So D to B to A. So, A can be anywhere over here. But we have to go through point B first to get there. So if I come around to point B and then go through A, that goes past 180. And so I do agree that that would have to be a major arc. Is ABC a major arc? So that would be from A through D through C. Well, the way that I drew it this way, it certainly looks like it is. But remember, all the answers that must be true. I don't know where A and C are. you know, what if A is down here and C is down here? So now it's not a major arc, is it? We don't know where A and C are, so you really got to be careful about that. Now it is named with 3 letters. That's true, but based on the picture, we don't know that A and C are divided by more than 180 degrees. It's not. Now what about BAD? So BAD has B and D, which are the endpoints of the diameter, as the endpoints of the arc. And so I like that because I know that I'm gonna hit exactly half the circle using that diameter. And so that is a semicircle. So my guess is that this one might have thrown people off the most, but let's go check it out. Yeah, actually, people missed A just as much as they missed whatever option E. So I think that's one of the big reasons people miss this is they picked too many options that weren't true. But these are harder questions, no doubt. We have to pick the ones that are true and eliminate the ones that aren't. It's kind of like getting 6 true false questions right in a row. So hopefully this problem, even though a lot of you missed part of it, at least it did teach you something about arcs. That's the whole point of it. Not very many people recognize DBA as a major arc. Now that one, starts with the first 2 letters of a diameter, so that means it has to be bigger than a semicircle. That one I was hoping would be a little more obvious, but hopefully you learned something from that problem. This was definitely another one of those emergencies that wasn't. Number 6, I am happy to say, was not as big of a deal. if a line and a circle are coplanar, there's three things that can happen. They don't intersect, they intersect at 2 points, or they intersect at 1 point. This was interested in knowing if they only share a single point. Notice it did say they were coplanar. And you guys knew that that had to be a tangent relationship. The definition of a tangent line, a line in a plane, and it intersects a circle at exactly 1 point. So good job. Almost everybody got that one right, and SpongeBob is happy for you. Number 7, you guys did pretty well on. Because HI and PI are tangents, we know that we have a perpendicular relationship. It did tell us that arc HP was 108 degrees. So what that means is that the central angle has to also be 108 degrees. So the only thing left that you have to remember is how many degrees are in a quadrilateral, right? 360 minus 90 minus 90 minus 108 turned out to be 72. Okay, so once again, this one was based on theorem 10.1 again. I think this is the third time we've used this theorem, that when you have a radius drawn to a point of tangency, it makes a perpendicular relationship with the tangent line. And as you can see, most of you, about 80% of you, got this one right. So, you know, not exceptional, but pretty strong. Good job, you know, good job. Chuck's happy with you. Thanks, Chuck Norris. Okay, number 8 was one that nobody got right, and I was pretty upset with that until I realized it was my fault. See, this is the problem I gave you. This is a brand new problem that I just wrote and typed up and built, and then as I was going around and writing the things in, I made a mistake. My mistake was right here. You can see that I accidentally duplicated one of the expressions. It should not have been like that. If you did it like that, you could have still gotten an answer, and a lot of you guys did, but it was supposed to be an 11x plus 3, not another 13x plus 9. I bet most of you guys set it equal to 360 and combine like terms, right? Here we have the proper one right here. The second line, this one was the one that had the wrong expression, and it still wasn't it. When you combine like terms, you should have gotten this expression. Let's subtract 3 and divide by 51, and we get x equals 7. So nobody picked 7 because you couldn't have. So that's my bad. If you did solve this top equation, and you ended up with 6.6 or 6.62, 6.623, then you set it up correctly. And I'll tell you what I did with that here in just a second. Unfortunately, my mistake on number 8 carried over into number 9. As you can see, nobody got the answer right on number 8. Nobody picked 7, but quite a few of you, 14, and another 1, and another... why this one didn't count. That's interesting. Somebody said 16.6. One person said 6.62. So actually, probably 3/4 of you guys would have gotten this right if my problem would have not had that mistake. But only one person guessed right on number 9, and that didn't have anything to do with the right answer actually from this point. So here's what number 9 should have been. Right? If we had the right picture and we had the right answer, 7, and we found our arc measurements, what we would have found out is that arc AC, okay, or arc, I guess it would be ABC. I guess you could have done ADC also, but would have been either 100 plus 80 or 108 plus 72. Both of those are 180 degrees. Well, that means that AC has to be a diameter, has to be, okay? Now, on the other hand, is DB a diameter? Now, a lot of people will be like, well, it looks like it goes through the center of the circle, Mr. Yamsek. That's true, but unless it gives you a line going through the center, you don't know that. But here's what we do know. We do know that arcs AD and AB add up to 172, and arcs BC and DC over here add up to 188. So that is the math does not support that being the answer. So this one was supposed to be just AC, but it was impossible to get this one correct. Remember, semicircles have to be exactly 180, and those are the only way to determine diameters without the line drawn through the center. So here's what I did, just so you understand. It was supposed to be a 20-point quiz. I threw number 8 and 9 out. Boom. That dropped it down to a 16-point quiz. If you did get number 8 right, I added a point into your score. So it kind of acted like a 1-point bonus. Okay. Number 10, we saw so many of these. Normally, people will miss these initially, but once you have done like 5 or 6 of them for practice, you realize that because of the tangent segment, right, we're using theorem 10.1 again, talking about the perpendicular relationship. We get a right angle because of the perpendicular relationship. That gives us a right triangle. The legs of the right triangle are 45 and R, so we throw those in for A and B. And then the hypotenuse is R plus 25. Now, most of the time, the mistake is right here. People forget to FOIL that out, but I imagine most of you guys remembered because a lot of people got this right. So you FOIL that out, you cancel the R squareds, right? The R squareds go away. We subtract the 625 and then divide by 50. And so the answer on this was 28. And as you can see, boy, only a couple people missed it. So really nice math on that one. And don't forget how to set up that problem. Good job, human. You just got a puppy high five. It's the best kind. The last problem on this was one you hadn't seen anything like it, and yet you knew how to do this because you know how to do algebra. I imagine, I think. Let me set this one up for you in case you see it again. It tells you points T and N are on a circle that has center A. Circle A, so center is A. Now where is A? It's at the point 4, -1. You don't have to be super accurate. You're just giving yourself an idea of what this looks like. So 4, -1 would be, roughly there. So I would make that my center, and then the points, -5, 2 would be maybe around there, and +7, -10 would be like way down here, right? So I mean, roughly that's where those points are. This doesn't have to be perfect. It's just giving us an idea of what we're looking at. So if this is the center, it should go through both of those points. Now, because I'm not graphing accurately, it doesn't look like it does, but I can I can draw the circle first and put the points on later. Remember, once again, this is just a little bit of a model of what we're looking at. So there's our circle, okay? And once again, this was point T, and this was point N, and point A was 4, -1. So determine the equation of the line that is tangent to a circle, to circle A, through point T. So, there's infinitely many tangents to this circle because there's infinitely many points on the circle. But in this specific case, they're looking for this this line right here. What's the equation of that line? I mean, looks like it has a positive slope. Looks like it has a positive intercept up here somewhere, but how do we figure that out specifically? This is just algebra, right? And we're going to use theorem 10.1 again, okay, in a plane. If a line is tangent to a circle, then it has to be perpendicular to the radius drawn to the point of tangency, okay? I know that if I draw a radius to this point on the circle, and remember, I estimated my point, so it's not going to be perfect, but it should be perpendicular. And the reason I need that is because you need a point and a slope to write the equation of any line, or 2 points. Because if you have 2 points, you can you can determine the slope by doing y minus y over x minus x. Now I only have 1 point on this line, so I can't find the slope. But I do have 2 points on this radius. So I'm going to say that the slope of TA is equal to y minus y, 2 minus negative 1 over x minus x, negative 5 minus 4. So that's 3 over negative 9, or negative 1/3. Cool. So remember, perpendicular slopes, because of this perpendicular relationship here, perpendicular slopes are opposite reciprocals. The opposite of negative is positive, and the reciprocal of 1/3 is 3. So now we have half of what we need. Actually, we have everything, because remember, we know it goes through the point T. And so now I have a slope and a point. I should be able to finish this off by using either point slope, or I think more of you guys are probably more comfortable with y equals mx plus b, slope intercept form. So the y value is 2, the slope we found was 3, the x value is negative 5. So this is negative 15 is what we get there. So I'm going to have to add 15 to get rid of that, right? So I add 15 to both sides, and there you go. And so with a slope of 17 slope of 3 and an intercept of 17, I end up with this equation right here. And so this was a hard problem because you hadn't seen it and you had to remember some algebra. But here's what I will tell you. A lot of you guys, so 4 of you guys got it outright, and one person was close, but you didn't write the equation. You didn't write y equals. You just wrote 3x plus 17. I think I gave you 1 point bonus, but the rest of you guys picked up 3 points on that, and so that's a nice little gain there. So I mean, good job. That's bonuses aren't supposed to be easy. If you think the bonuses are going to be an easy problem for you, then that is cute. But I know that next time you see a bonus, you're going to give it a good shot and not be afraid of it, because you like the challenge, don't you? That's what I thought. You let me know if you have any questions on this quiz that you still don't understand why you missed them, and I'll try to address those for you as well as I can. But otherwise, try to learn from your mistakes on sections 10.1 and 10.2, and we'll do another short quiz at the end of this week and make those adjustments. That's what learning is all about, right? Making those adjustments. Thank you, and be well.